chapter 11. Now these are the last two. Chapter 11 and 12 are both on statistics. Today we'll be primarily looking at how to set up what statistics are used for, maybe doing a study, a survey. So a lot of it is sort of vocabulary based, and then we'll be looking at things like where's the center of the data, the mean, the median, the mode. So we'll look at those.
Median, mode, and range?
Range is something different, but then the dispersion includes the range, the standard deviation, and those kind of things. So we look for where the center of the data is, and then how spread out that data might be. Those are the two measurements we have today. Next week, we get into, we put all that together and we do what's called the normal distribution, which is done a lot in research. So we won't get too far ahead, but what we do today will also be used next week. And you can see here, I just added, there is a stats calculator. So there's a link to it, and where it'll take you is right here. And what's really nice about this is when you're doing the homework, a lot of times you can just copy the data from the homework system, post it in here. It'll have commas and everything, and it will actually give you all the information you need. We'll talk about what some of these things, some of them we're not using, but yes, we've got the mean, median, and mode. It'll calculate it for you. Okay, so we'll describe what those are, how to calculate them, but for the most part, we'll use a tool to do the calculations. So we've got this Tuesday. Next Tuesday is, again, another day. Thursdays are work days. And then we have final exams the following week. So we got 2 weeks of classes, 1 week with finals. And you'll be able to take the final during class time, is how we do it here, on either Tuesday or Thursday. So if you're ready and want to get it done, come the Tuesday of finals week, take it, you're done. If you want more time to study, come Thursday, take it, you're done. Any questions about anything else?
When are we going to do the presentation?
Presentations are somewhat individualized, so we could do those on any Thursday on a work day, or Tuesday, like next Tuesday, if you're ready, we could do it after the lecture. During the final exam's not going to work real well. The other thing you can do is you can also do it by recording it, phone video or something, of 4 to 6 minutes. And I'm going to change it so there's no written component. All you'll have to do is once you post your video of your presentation, that's all you'll need to do. Don't need a PowerPoint or anything. I mean, you could just talk about it. You could have some visuals, whatever. But oftentimes the video works. Again, I had one who did, you could see the different examples, but she was doing the mathematics of a fish tank, and not overfeeding, not underfeeding, and pH and all that kind of stuff. And
basically, you can improvise the whole thing and still get full credit.
sure. The main thing is that you've looked at how math is used in something that you do on a regular basis. The goal is to find something that you enjoy doing, or something that, your major, your hobbies, those kind of things.
And find the math involved in it.
And find the math, yeah. So that all happens. The presentation is just to show that you did something. Okay, so let's go ahead. And I used a different book, so they say chapter 12, but this is actually for chapter 11 for our stuff. Okay. So we're going to talk about data in the big picture. What is statistics? So statistics is a word we use for the science of statistics, of data analysis, but we also use it to refer to the data itself. Okay, so sometimes they'll say the statistics, that's referring to the data that has been collected. Thinking back to when we did probability, right? Sports, you have someone collect all the stats. That's how they're able to know somebody's batting average or something, collecting data. So we're going to talk about how to do that. There's two types of statistics. One is descriptive statistics, which you take and it summarizes data, maybe your ages. Then we could have an idea of how old people are in the class. That's more of a descriptive. And then inferential statistics, which we can use to draw conclusions. So we might say your test scores might be predictive of how you'll do in the future. So those are statistics that allow us to make an inference of how you'll do. And that's what most entrance exams are about, is how successful will you be able to be in college, or jobs sometimes will have have you take some kind of an exam before you, maybe as an interview process. And the idea is that that exam, how you did on that exam, will tell you where you fit in the company. Sometimes it's not a right or wrong. I've had personality type tests done when I've applied places, and they use that to kind of say, which group would you be the best fit for? Are you going to be the right person for this? So it's, again, it's not right or wrong, it's just how are you going to do? So then there's again, this is a lot, is just vocabulary. Population. Population is the whole group we're talking about. Now, it might not be, we think about populations, all the people in the world, right? Well, we could talk about the population of college students. So that would be all college students everywhere, if I leave it open. It doesn't have an age restriction, because as long as you're a college student, you're in there. But it would be someone who's not in college would not be in that population, right? We can restrict it a little further and say the population of students in the USA. Okay, so population is all those that are included. When we do a study, though, oftentimes we take what's called a sample. So we don't go ask every student in the USA about what their opinions are. We ask 1,000 students what their opinion is, and that's what the sample is. Okay, so that's that kind of clear medical term, right? You take a sample out of the whole. You don't take everything, you take a sample. Okay. A representative sample is taken in a way that means that it represents the whole group. So you've got a diverse side section. So if there's 6% female or 20% this or whatever, you've got that in your sample, looks very much like your population. Okay, so if we want to get a feeling for how a population feels about something, we need to know what the population is, right? So the example we're given is a group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. So who's the population? Is it all people? Is it all people visiting the city? It's a set of all citizens. So we'd have to define that a little bit. Is that people that live here? Is it, in Scottsdale, especially in this area, we have a lot of snowbirds. So those people who come for 6 months out of the year, would we want to include them? Or are they just long-term tourists? So you've got to decide, who you're looking for. So how can we get a good sample? So one hotel owner suggests obtaining a sample survey all the people at 6 of the largest nightclubs in the city. Each person is asked to express their opinion. So would that be a good idea if you want to find out how people feel about casinos, is to go to the nightclubs? Would that be representative of all citizens? Maybe not. It would be certainly representative of those who like nightlife. They might be very favorable to casinos. And again, that's what this says, is that you're likely to have people who have an attitude towards casino gambling. Okay, so you wouldn't get, but maybe that's what they want. So you got to be careful about studies, because sometimes they do try to skew the results. How did they choose their sample? So one of the things we can do is select a random sample. And a random sample simply means that everybody in the population has an equal chance of being chosen for the survey. Now, not all of them may survey, but you need to have an equal chance. So you don't just go to the 6 nightclubs, but maybe you have some list of all the citizens, and then you could go through those lists. And typically what it does is you've got that list, you assign a number to each of those lists, and then you have a computer randomly select the numbers, and those will be the people who are surveyed. And typically that will give you, because of the randomness, it will give you a better representative sample. Okay. So randomly survey people who live in the oceanfront condominiums in the city. So would that give you a true random sample? No, because you're getting a particular subset. So again, they might not like, again, you might get a group that like it or not. There's a big thing in Tempe recently, right, about noise, because they put in a retirement home. The older folks didn't like all the noise, but the people who said, hey.
They put it on university.
What's that?
They put it like on university.
I think so, yeah.
Yeah, so like, can't really expect.
Yeah, I know. I mean, it was, what do you expect?
Yeah,
People
like,
got to
it's
live.
just like what you get.
Yeah, exactly. What was there first, and then now you're going to change it. So, but anyway, so that's the thing that happens is certain places will do that. How about survey the first 200 people whose name appear on the city's telephone directory? Who are you going to get then? Could be random, or it could be representative, but probably, since it's alphabetized most of the time, you're getting all the people with last names of A. So it might not be as diverse as you think. It's not random, certainly, not equal chance. Randomly selecting neighborhoods in the city and then randomly surveying the people, that's a little bit better, but again, if you select an area and then you go in there, you're getting maybe not as much cross-section of diversity as you like. It says it gives you an equal chance, but again, it's a system that's used, but it can also, and what we've seen recently is in the voting, they redraw districts. Whichever party's in power seems to make the district fit so that they're going to win that district, right? So I'm still, worried about that. So now we get into the math, the more mathy part of it, the numbers. What does data look like? It looks like a bunch of numbers, right? And all randomly chosen. So this is this data that we have is the age of maximum yearly growth for 35 boys. So some by 12 years old, they would reach their maximum height. Some by 18 reach their maximum height. They stop growing. I had one of my best friends going into high school. We were about the same height, but then senior year, he had a growth spurt and it was almost a foot growth in that last year.
So this is where the calculator comes in.
This is where the calculator comes in. And so we're going to want a frequency table, what that is we want to get them into groups. How many 10-year-olds were there? Well, there's only one, and so there was a frequency of how often 10-year-old occurred was once. There's 2 11s in here, and again, it's hard to pick out until you start looking, but you kind of just go through the list and you're putting the list of how many of each are there. And now when you've got this in a frequency table, it's a lot easier to see, 14-year-olds had the most, right? Looking at the raw data, you don't really get that much of a picture of that. Okay?
It's only when you break it down that you really kind of...
Right. And so this is part of it, is just finding ways to display it. We're going to, sometimes just the table itself will be helpful. We're going to see they also do charts from these, bar graphs, and so forth. So what are some of the conclusions you can draw from this now that we've got it in this form?
Obviously, as you just said before, the most amount were 14.
What else do you see? Anything? Okay, so there's only one of each of those, and there's no what? There's no 9-year-olds. There's no 19-year-olds. We don't know if maybe those might be outliers, but it might seem that nobody reaches their maximum height by 9-year-olds. And so there's sometimes you can tell things by what's not in the data. Okay, maximum growth 12 to 15. The other outsides, less growth. The boys who attain their maximum growth at 14 decreases after that, so we see it kind of getting bigger and bigger, and then 9 of the boys was at 14, and then it goes back down. Okay. Here's a class of 40 students and potentially test scores. Again, we'll do the same thing, group them into frequencies, but what we want to do is if we had if we list them each by each number, notice, let's see, what's the lowest score here? 57? Is there anyone see anything small? 54? It's kind of spread out, right? So another thing we do is we put them into classes. Okay, so scores from 40 to 49, 50 to 59, 60 to 69, so forth. And then what we do is we count how many test scores are in each of these classes. I can't remember if I filled them in or not. So, and again, it's kind of tedious, as I said. It was, let me get my, so what you'd end up doing is the class of, say, 40 to 49. Oh, there are some here. So there's a 45, a 43. Any others in? So we'd say that has a frequency of 2. And you do the same thing, 50 to 59. And again, it's nothing magical. It's just tedious. You just look, oh, I missed a 47. So I have to come back and say it's not 2, it's 3. Those that are in the 50s. So I got 1, 2, 3, 4, 5, 6. Okay, so you see how the process is if you need to make a frequency table. It's just tedious finding those and easy to make a mistake. So a lot of times it's very nice when they provide us with a frequency table, right? You'll see this use of the number n for number of people in the sample. So we've got 40 in there, okay? And we do that. Let me, while we're at this, I think I do it a little bit later, but we'll do it here as well. So this is a frequency, it's a numerical value. One way we can compare a set of data to another set of data that might be a different size. Maybe we had a class of 100. How does this compare? How do these test scores compete? And what we do is we do what's called a relative frequency, which is really just a percentage. And from doing percentages, do you remember how to calculate? How would we calculate what the percentage from 40 to 49 is? There's 3 here out of 40. How do we calculate that as a percentage?
3 dividing 40?
Good. 3 divided by 40, that's going to give us a decimal. And so if we want it as a percentage, we can multiply it by 100, right? And then that turns it into a percentage. So we could do that with each of these. For 70 to 79, say, it's 11 divided by 40 times 100 will give us relative frequency. Okay, and again, that's something that like Microsoft Excel is good at. You can do formulas and just turn raw data into a frequency table and then into a relative frequency table, which makes the use of this wider spread. Okay. Another thing we can do is we can turn it into a bar graph. So this is the data of the growth rate of the boys, and we can see at 14 has 9. So it's just a visual representation of it. Okay, so a bar graph is just taking those numbers and making it visual, and we can see the pattern maybe a little bit more clearly than when it was just numbers. Frequency polygram is another type. It's related to the histogram. What they do is they put a dot at the top of each of these bars. They erase the bars and then connect the dots with lines. So it shows the trends, but it's also a little misleading, because if you take the bars away, then it looks like you're following along this line when it's really just particular pieces of data. Okay, stem and leaf plots, they can be useful, and what a stem and leaf plot does is we would use, say, the tens value as the stem, and then the leaves would be all the other digits. So we might take like 4 to be one of the stems. So we'd write 4 here, and then we would arrange the units digits. So there's 4, 45, 43. So what we would do is we'd go 43, 45, 47. So it's kind of telling us that there's 3 things that are in the 40s. But we could reconstruct the data because we know it's there. And then for 50s, we'd put a 5, and then we'd list all the values in order of the 5s. So we got a 56, we've got a 50. And if you had 2 50s, you'd put 2 zeros in a row. I don't see 2, we got 2 57s. Where's another 50?
59 in the bottom.
In the bottom, thank you. So then there's a, let's see, a 54, 56. There's 2 57s, so we do it just like that, and then a 59. So that's what a stem and leaf graph is. Again, just to kind of expose you that it's something that could be used. In reality, I don't see it used very often. So, but it keeps the data, and it sort of organizes it. But again, you might find a good use for it in whatever you're doing in analyzing. Okay, so the leaves don't have to be in order, but oftentimes if you do put them in order, it's kind of nice, because if they're not in order, you know, but it gives, again, it sort of also gives a visual of a bar graph that way. Okay. One of the things we want you to do is be careful about deceptive graphs. Oftentimes in newspapers they put things, and so what about this last graph on the right and the first one? What's deceptive about these? Because they're the same graph. Which one looks more drastic?
The one to the left.
Yeah, it looks like
they're making it go up more, but then just to exaggerate it and for dramatic effect, while the actual thing that is happening is that poverty is slowly increasing.
right.
They
So,
just are doing that with the graph to make a point.
yeah, they've zoomed in. Now it might be that, you know, 0.1% is a big difference, you know, especially if you're the one in poverty, right? So which one's more accurate? They're both accurate, but we just have to look that this one is definitely more zoomed in. This one might be saying, hey, it's not really a problem, but they zoomed out. So you see, depending upon what kind of point a person's trying to make, or an organization, they might show it in different perspectives. And we just have to look. They're both the same data, is an increase from 11.7 to about 12.7. That's a 1% increase. Is that important, right? And this table is the same. Okay, so we can make it either look slow or look fast. So things to watch about is, does it start at 0? Has it zoomed in? Are they maybe sensationalizing something or trying to minimize something? Those are things that can make a difference. Okay, so just be careful, because we look through articles, we see this picture, oh yeah, it's going off the roof. Well, maybe they zoom in and it's really not as bad as it looks. Or maybe there are people who want to say, hey, this thing is not a big deal, and maybe it is. So watch for that. And again, you've got 6 points you can look over. Also look for the source. Who's providing the data? You know, if it's on this big issue of gun control lately, right? Is it the National Rifle Association that supports guns? If they're producing something, it might be, well, that's why it's favorable towards guns. If it's on the other side, maybe they're making their data to look the other way. So there's both sides of an issue might tend to give us very conflicting views of the same data. And again, we want to be able to, the goal of it is being able to analyze the data as it is and make those decisions for ourselves. One of the things is when they, like this graph down here, the area is so much bigger, but it doesn't actually, and I think that's the last one, it doesn't actually apply all that much. It's not as big, the differences are not as big as the graph that they've drawn. They're really only using the height to represent the differences. But because they also use area, what you see is the biggest area seems like a bigger difference. Okay. So what I'm going to do now is I'm going to go ahead and jump in, because the next part is calculating mean, median, and mode. I'm going to actually jump into the quiz, because I'm going to, we'll see how to do that, because the calculations will get made. So if you want, you might want to have this open so you can kind of get a little bit of experience using it. Some of the data is easy to just transport over. Some of it is not as much. Okay. Let's see if we can make that a little bit bigger. There we go. Okay. So this first one, not really a calculation, but so part of what we want you to do is be able to read the bar graphs. Okay. So Frisbee Golf Club recorded the ages of its members and used the results to construct this histogram. Find the number of members 25 age or younger. So how would we count that?
Well, obviously we have the number of people on the side, and then the ratios, on the X, I guess on the X, what number on the Y. That's kind of our reference point. Kind of just go see the maximum of each one, starting from 25 to 21 and 20 to 16, taking their maxes and just adding them together.
Okay. And what do you see for this particular problem?
So, for example, there's only one person who is between the years 21 and 25, and between 16 and 29. So 10.
Good. Does that make sense?
You can just add.
Just add them. Yeah, so nothing big. But had they asked the question, how many are 23 or younger, could you answer that with this graph?
No.
No, because we don't know. We know there's one in there, but we just know that they're between 21 and 25.
Yeah, like it would probably require some serious guesstimations.
Well, yeah, it would require us to make an answer on something we don't have. So we can say 10 are less than 25, but we couldn't tell you. We could tell you it might be 9 or it might be 10 that are less than 23, but that's all we can tell you. So we're looking at that. Yes, the mathematics is not so difficult. This one is actually, we'll look at a little bit more. It's not even in my slides until next week, but shapes of distribution. So these are frequency charts, and so the higher the bulge, the more frequency there. What I'm going to tell you is that there are three types. There's what we call skew to the data. Data skewed one way, so that means a lot of data is either at the high end or the low end. There is also called uniform distribution, which is a straight line. So I'm going to go ahead and this one with the straight line is going to be a uniform. Everything, all the data is the same. Okay. This one is a bell-shaped curve, and that's called a symmetric or bell-shaped. Okay.
Now, I did go ahead and answer this one ahead of time. The left and right skewed are a bit confusing.
They are, because what they're talking about is where is the what we would call the outliers of the data. So if the outliers are to the left, and outliers are there's just a small amount of data. So this first one, yeah, you look at it, you're going to think of it maybe as right skewed because the right has more data, but it's actually left skewed because that's where the outliers would be. Okay, so looking for the small end is which way it's skewed. So this last one on the right, what kind of skew does that have?
Right skewed.
Very good. So it's just kind of training our mind to go with, again, it's more about definitions. So I always look at them and I get them wrong, so I've taught myself that, no, it's not where the bulge is, it's where the low part is, okay? But it's kind of like that. If I had a slide, that's exactly what it would show. Okay, we doing so far so good?
Mm-hmm.
Okay. Consider the following data set, round your answers to the nearest, and we need to get the mean, median, mode, the range, and the standard deviation.
So can we just enter this into the calculator and get what we want?
Well, let's see. Let's see if we can copy and paste it. I know with some of this it works. So you select the data, and I'm going to do a Control-C, which should copy it. And then I'm going to go to my calculator, put my pointer in there, and I'm going to Control-V, paste the data. Now, I'm going to calculate. I don't know if it'll work or if I need to put commas. It's been a while since I used it. Let's just calculate, and hey, it even put the commas in for me, so it read the data as distinct, and it got my answers for me. So yes, you can just copy and paste. You could also enter it in individually if you want to enter each number and then put a comma and then the next. So commas separate your data. So be careful if you got things in the thousands, you don't want to use a comma with that number. So sometimes we're going to have to take that, because otherwise this thing will see it as two pieces of data, right? 10,506. If you put that comma in, it's going to separate it. But notice we've got all the data we need. It gives us the minimum and maximum values. So it looks, okay, there's 13 was the smallest, 55. But it didn't ask for that. It did ask for the range, right? Range is taking the biggest piece of data, subtracting the smallest. So that's what the range is. So if you took 55 minus 13, you would get 42. So we can come back here, range, we could go ahead and put 42 because it got it for us. It's got the mean for us. What that is it took them and added them all together and divided by however many there were. It will tell us, and there was 10 pieces of data. That's what the end tells us. Okay, so actually if you take 385, it added it together, divided by 10, you get 38.5. But notice it's going to give you the mean. So I come back here, mean is 38.5. Median, that's going to be the data, the number of, that's in the middle. So what you do to get the median is you line up the data in order from smallest to largest, and you get the middle piece. Well, if there's 10 pieces, there's 5 below, 5 above. And so to get the median, you actually have to go halfway between. But again, this is going to calculate the median for you. It ends up being also 38.5. Does anyone know what the mode is?
55?
Why is it 55? Because 55 occurs 3 times in the data. So the mode is simply the one that happens the most, the greatest frequency. It doesn't really tell us about the central, right? But it's not the average, it's not the median, it's simply the one that happened the
I
most.
always get median mixed up in what their functions are, like, because I know that one is where you find the one that's in the center, in the middle of the data, and then the other one is where you add up the data times how many bits of data there are.
Divided by,
Divided.
that's the mean. Yeah,
Okay, so,
Average.
the average, yes.
and then I forget what the range was.
Range is the biggest minus the smallest.
Okay.
And then sample standard deviation. What you'll see is we come down here, it gives us the standard deviation,
Yeah, and it says, and it basically says round to the nearest hundred, so in this case,
14.6.
How is that calculated for standard deviation?
You had to ask, right? So it's a whole calculation. Okay, so how do we get the mean? And I do have a video that will show you all these steps if you're interested, but what I'm gonna have you do is use the calculator to calculate to get what the standard deviation. We use it a lot more next Tuesday as well in that lesson. But you get the mean, you add all the numbers together, so like 5 plus 6 plus 7, let's say.
Could I take a picture after you write it down?
Sure.
Thank you.
Let's say we have, we'll just go with 3 pieces of data. Right, we'd add them together, divide by 3. I chose some real easy data. This is 11, 19, wait, 11, 18. 18 divided by 3 is going to be 6. So that's our mean. To get the standard deviation, so we calculate first the deviation. So we take each piece of data and we're going to subtract the mean. So that's sort of the first step. So that's the deviation part. But notice when you do this, this will give us a -1, this gives us a 0, and this gives us a +1. If you add all the deviations together, what do we get?
0.
And that happens every single time because the way we get the mean, if we subtract it because of those numbers, you'll always get 0, so it's not very helpful, right? So what they do is they will square the deviation. Okay, so this is a standardizing process. So we'll take -1 and square it. We'll take 0 and square it. We'll take 1 and square it. And that gives us all positive numbers. And you could see if these were, if I didn't choose such nice numbers, I could have some decimals in here, and then you gotta square them, you'll get various numbers here. So that's your deviation, just your squared. And now when we add this together, we get 2. So that's kind of the squared deviations. And what we do is we're going to, since we squared it, we unsquare it. And then to kind of get what the average deviation is, we subtract the number we have less 1. Okay, and why less 1? Again, this is all a system that comes up that basically it works. It makes it a little bit more. It's a formula. Yeah. And so that's going to be 2. So this one would be square root of 2 over 2. which you could plug in a calculator and get a decimal. That's what this is gonna do for us. The thing is I don't spend a lot of time in having you do actually any of these calculations, because you don't really learn a heck of a lot, as long as you know that the standard deviation does involve finding the mean, where the middle sort of that data is, right? Subtracting it from each piece of data, so you're getting how far away it is. It's gonna square it and then unsquare it and get an average. So it's sort of the average distance away. And it's not, all it does, it tells us if it's got a big standard deviation, we know our data's got a lot of spread out. If it's a small number, it means everything's close to that middle number, okay? And this obviously, this square root of 2 is like 1.4 something divided by 2. This is actually less than 1. So you could see, here's our mean. Everything is like within 1 of, it's very close, very packed.
Is this a good time to take a picture?
That'd be a perfect time. Yeah.
It's basically, it's a tedious process, and we should just be thankful we have a way to calculate it without having to
Yeah,
worry about it.
and in the end, just know that if it's a bigger number, it's telling us how spread out from that mean it is. That's all it is. We'll get a better feel for it when we do chapter 12. Okay,
Do
chapter
we
12.
really use this number in the real life?
Only when you're doing statistics. So yeah, but and that's where it becomes important, is most statistics is done with what's called the bell-shaped curve. That's the normal curve. I'll tell you sort of, I have a take that it applies for some things, but a lot of things it's applied a lot in education for how people are doing.
It kind of makes me just think about like that cliched math class question of when will we need to use them?
Yeah, when you're doing statistics. So if you're a statistician.
It's not everything.
But where you might need to, as a consumer, it's more important. You will see reports that talk about this much standard deviation. If you have children, they're growing. What is there growth within so many standard deviations? How do you know if your child is, if they're just small for their age, or if that's an issue? I had 2 cousins. They figured they weren't growing much, but they didn't know if it was they had them tested, and they actually had a genetic, they had a type of dwarfism. Fortunately for the younger one, they caught it early enough, they could get her some medicines, and she was fine. The other one, he was, by the time they figured out, he was older, and they weren't able to help him as much. So there's some things like that, if you're so many standard deviations, this is not normal. So it helps us to look at those kind of things. Okay, so we got all these, and so what was that? Was 14.64,
Yeah.
if you want 2 decimal places. Okay, and again, we can just click here and it'll show us all our answers. But that's the thing, is that we'll get those answers to you, and by using them, we'll get there. 5-number summary, so let me show you what that is. That's going to be taking 5 numbers. I believe we can also copy this. So Command C, copy the data. We come here, we can clear the data. And Control V, we can paste the data. Then we can calculate. And it took it just fine. Okay, so that's kind of a nice feature. That's why I like this particular calculator. The 5-number summary it's looking for the minimum and the maximum, the median, and actually you'll see the median's the quartile. So it's these are 3 of the 5 numbers: first quartile, second quartile, third quartile, and the minimum and maximum are the other 2. So what you're getting is you're getting the smallest number and the biggest number. You're getting the median, which is right in the middle. Quartile 1 is 25% through the data, and quartile 3 is 75% through the data. Okay.
Does the order matter?
It does. You're always supposed to list them from smallest to largest. So we want to go with 24. and then the quartile 1, quartile 2, quartile 3. So again, this data gives it to us. What we would have to do is line up the data in order, and we could actually locate this data, but again, this will do all that. So then it's 54, 75, 82. 54, 75, 82. And watch, the 75 is the median also, so when we go to the median, it's 75. You'll see that. That's the second quartile, another name for it. And then the maximum number is 96. So this type of calculator takes the tediousness out of it. And again, if you're going to be using statistics, usually every modern statistics course is taught with a statistics software package. You put the data in, it gives out, and then your job is to, what does this data mean, to analyze it. Check our answer. Yeah, we got it all right, because the calculator did it for us, right? So we're going to be just fine. Now, we've just got 2 more questions. So what they do with the 5-number summary is they can actually make a chart that's called a box and whisker, okay? And with a box and whisker plot, there's what we're going to see. There are, let me change the colors here. There's 5 lines. This one at the end is the minimum number. This is quartile 1. This is quartile 2, or the median, right? Because those are the same thing. This bar here represents quartile 3, and this last bar here represents the max, the biggest value, okay? And then you could just drop down and read it. So it looks like the max to me is like maybe 56, right? The third quartile is 50, the median's 45, and so forth. So this is a construction worker. The teachers, they've got different data, but they're plotted here. So there's a minimum, quartile 1, quartile 2, quartile 3, and a max. Now watch, if a person is making the maximum salary for a construction worker, so who are we talking about? This. They are making more than what percentage of the teachers? So how many teachers are below this amount? What percentage? Well, let me ask you this. 100%. Good. Yeah. What? They're all there, right? Exactly. 100% of them. None of them are above, so they're all below. And when we break this up, the reason they call this a quartile is this is 4 pieces, right? This is 25%. This is 25% of the data. This is 25%. And this is 25%. 100%. So for the teachers, 25, 25, 25, 100% of them are below the maximum. Not a hard question, but it just seemed like, why do you need to ask, right? And again, on this question, you might get a different one. Notice.
In my case, I mean, the values are different, and it's asking you for the median.
Okay, so if we looked at the median, you probably have the same graph. So the median is right here, right, 45. What percent of teachers are making less than the median of a construction worker? 25, 50, 75%.
Okay.
Right? So again, it's just whatever the question's asking. So yes, if they
Yep, 75.
what percent of teachers less than Q2, or the median of construction? And again, we say, okay, here's the construction worker. So it's this 25, 25, 25. Okay, so again, it's just to introduce you to this other concept of 5-number summary, box and whisker plots, and how they work.
Mine's asking for the first quartile salary, and I'm a little confused.
First quartile salary of what? Of a construction worker? or Okay, so the first quartile salary is right here. So they're actually asking for an amount that would be 35,000, at least on this graph. So that's how. So they could be asking multiple things, but if they're asking like percentage, so I guess they have this question set up in multiple ways. But does that make sense? That we're
It's asking to, the percentage.
okay. So
Here.
read the question to me.
If a person is making the first quartile salary for a construction worker, they're making more than what percentage of teachers?
Okay, so we do the same. So the quartile comes down here, right? And then what percent of the teachers are below that? 25 and 25, so 50%. 50% of teachers are making less than that salary. Does that make sense?
A little bit more, yes.
Yeah, so they're using one to compare to the other, so it's just kind of, okay, here's where the first quartile is for construction workers. That includes basically the first and second quartile for teachers. But go ahead.
The confusing part is just because each quartile is not the same.
Right. It contains the same amount of people, but it might not be spread. That's showing us that, this to this might include, it's 25% of the people, but yes, that could be smaller or larger. So it's showing the spread. When it's larger, it's showing a greater spread of the data. When it's smaller, it means it's kind of compact. And it's, kind of, but each segment is 25% of the data. Okay?
Why don't they make it like equally?
Because it's designed to show the spread, how spread out something is. So it's simply based upon the data. So if the data could be equally spread out, like on, maybe you're paid by however many years of experience or something, you could see ones that are equally spread out. But this, or you could see ones, I've seen some that are like this. It's telling you the middle group's real packed, but actually there's the same number of pieces of data in both the long one and this one. It just tells you that this data over here is very spread out. And then you might just have a little thing like this. So at the upper end, the data is all very compact. And maybe that's where all your employees, and they're all making similar, but there's maybe a few employees who are part-time. These might be your part-time employees, so their salaries are so much less, right? And then all these are your full-time, which you're paying similar amount. So that's why it's not all equal. And that's one of the concepts to pick up, is it's used that way. Okay. But each set is, each of the 5 numbers, between each of the 5 numbers is 25% of the data. So in general, blank percent of the values in a data set lie at or below the median. So if you're at the halfway, the median, what percent is below the median?
75? 50.
50. All right, half.
All right, half.
Always, yeah. So the median is going to be our 50%. Blank percent of the values of the data set lie at or below the third quartile.
75?
75. Think of 3/4, 75 cents, right?
It's basically the property of 25.
It is. It
That's
is.
25.
If a sample consists of 1,900 test scores, blank of them would be at or below the second quartile.
It's the median, isn't it?
It's the median,
50?
50%. What's 50% of 1,900?
Let me just calculate.
1,900. Either times 0.5, because that's 50%, or divided by 2, you'll get the same answer.
950.
And for this one, it's 1,900, 1,900, and so we want half of that. So 1,900 divided by 2,
950.
950. Again, you may have a different number in there, but it's just basically an application. And then if a sample consists of 1,900 test scores, blank of them would be at or above the first quartile. So how many is above the first quartile?
75.
Good. 25% is below, 75% is above. So it's
times 0.75.
times 0.75 times 1,900, and that tells you the number of pieces of data, which is
Hold it.
1425.
1425.
Thanks.
Oops, I forgot to answer this one. At or below the medium. I said it, but I didn't put it in, or maybe I did. Okay, so that's what this section takes you up through, that 5-number summary, which divides the data basically to quarters, from lowest to highest. 25% of data is always going to be. It's just because that's the way it's formed. Next week we're going to just kind of build on this, and we're going to use the mean and the standard deviation, and look at the bell-shaped curve, the normal curve, and use it to do some calculations.
Crazy to think it's already almost May.
It is.
We're blowing through 2023.
Yep, more than. Summer's almost here, finally. Okay.
I'll be able to finally, me and my family will be headed to California. We'll also have a trip to Universal Studios.
Very good. So that's it for today. Make sure you've got that link. It's in Canvas. It's very helpful. It will do all the calculations for you, but again, kind of work to understand how to apply these and how you might use them. Start thinking of some 4 to 6 minute presentation you can do. You can record it yourself. You can come in, again, any of these days we have in this coming week. If you want to just do it as a conversation with me. I've done that with students before. Let's just talk it through. We'll have a 5 or 10 minute conversation about how you're using your math, and that's perfect. Sometimes then they still want to go do a presentation. I said, well, you're done. No, I want to do the presentation. Okay, go ahead. And they do some good work. So anyway, thank you. And
Presentation just for you.
yeah,
You
it's,
don't have any.
you don't have to, yeah, because I always do that because some people, I'm so nervous, I don't know all these people. Yeah, so it's not about being nervous, it's about you just applying the math and being able to communicate it to us.
So
Thank you, Dr.
Thank you.
Locro.
Pleasure.
Dr. Locro, before I head out of here, I do want to make sure that I know where the